Okay, well, hello everybody, and welcome to another presentation of the online ColdFusion Meetup. I'm Charlie Earhart, and I'll be your host for the next hour or so. And in this edition of the Meetup, our 260th, being recorded on Thursday, June 18th, 2020, at noon U.S. Eastern Time, we've got Josh Patterson, who's going to present on how to transform DB tuning into a rewarding effort. And with that, thanks, Josh, for coming on. And I'll go ahead and stop sharing, and you can share your screen. Take it away.
Okay. Thank you, everyone, for joining. This is my first of one of these types of formats, so I hope you'll forgive me if I have any little blunders. But I also want to make sure that this is as informal as possible. If you have questions, please feel free to chat those over. We will monitor those and uh, answer them as best we can. So basically, I've spent my career attempting to tune databases in two different ways, the technical side and kind of the political side. And basically, what we end up with is we have databases which don't perform very well. We know they don't perform very well, and we need to tune them, and we need tooling. And sometimes there's a battle about how to get the tooling and what is the right tooling. So I wanted to give people some of the tools for some of the personal tools for how to actually get those tools and make their databases perform the way they should. So I've tried to break this down into sort of the why, who, when, and how of database performance tuning. So sorry, I'm actually working from home today, so I do have kids here, which is not normal for me. So the very first thing I want to jump into is the why. So if we have any application developers, database developers, administrators, anyone on, you'll know that the database is very often the center of performance related issues. Uh, for instance, this is a Gartner report that actually came out several years ago. It wasn't super recent, but times haven't changed much. Uh, correspondents actually showed that, or respondents reported that 88% of their database or their performance problems were database related, which makes sense. It's a very often neglected part of the application development lifecycle. Spent much time there. So the other thing is that you often find that you have low server utilization rates, which sounds really counterintuitive. But when you look at a SQL server, or a lot of database servers, but SQL Server in particular, in my experience, you'll see that throughout the day and throughout the night, your quiet times and your peak times, you've really got about a 20, 30, 10, 20, 30% utilization rate on things like CPU. Memory could be high, but CPU is usually pretty low. So why would you have so many resources thrown at something that only needs uh, uh, 10, 20% of its actual resources? Again, spread over time. We can actually find ways to offset that. If we have different types of workloads, we could combine those and share individual resources if workloads are tuned properly. So that's something we'll talk about as well. Um, so in this 2014 Gleanster Application Performance Management Survey, we have the 76% report after performance problems in production. Uh, teams are usually going to logs. They're looking at event logs and they're looking at some perf stats that maybe they had pulling from this tool or some other tool, or they're asking people what did it look like, or maybe they're using perfmon, but they're manually gathering the data that they need to make decisions. And importantly, they're gathering that data after the fact, almost always. And again, 88% cite that database. I don't like those 88% numbers, but that actually was the number. And lastly, on this slide, we've got the 71% of respondents indicate that application performance management tools only provided hints. We hear that all the time, and it was actually one of my biggest problems back in the day, demoing lots of different tools and trying to determine what it was we were going to use to help us solve our problems at some of the companies I've worked at in the past. And we found that more often than not, um, the tool was just a little vague. It said that, yeah, your CPU is high, but it didn't tell me why. Or, it would tell me that my utilization was extremely high, and it would barrage me with, you know, hundreds or thousands of queries that are the problem. And it's just not the case. Your problem is almost never every single statement hitting your server. Sure, there are some possibilities where that could happen, but it's typically, especially if your performance is typically okay, and maybe one day it's bad, or maybe some days it's worse than others. It's usually going to come down to a couple of SQL statements or processes that are going on that are consuming resources, blocking resources, or just putting an overall strain on the system. And usually those are low-hanging fruit. There's no reason that a tool can't point those out. So moving on to the who, we've got the who needs to tune their databases. I'm sure you knew the answer was everybody. But actually, there's a point I'm trying to make here, and it's kind of personal to me because for the first half of my career, I was not a database guy. I was not a database specialist. I would start at a position as an application developer, and then every time the database responsibilities would fall on my lap. And it's at the time, it's not even really because I was good at it. I actually enjoyed doing it, which I think is why it usually landed on my lap. But the important thing to understand is that a lot of these companies neglect their database resources, the hardware, the queries, all of your different aspects of tuning that we'll talk about. Uh, so it's important to remember that just because you have a database does not mean that someone's taking care of it. You might not have a database administrator. A lot of companies don't have database administrators. And if you do have a database administrator, he likely does not think it's his job to tune queries that are coming from some website that a developer wrote at the company. And sometimes he's right. Database administrators are responsible for, as we say here, operations, backup, clustering, adding hardware, and it's the responsibility of the developer to tune their code prior to reaching production. And this doesn't have to be some big, robust software development lifecycle. If you write code that hits the database, your code should perform. If it doesn't perform, it's not your fault. If you don't have some way to tell whether it performs or whether that performance changes over time, it's just not possible to track it and instrument it and baseline all of your SQL statements that are being produced by your website or application all the time without some method of collecting, aggregating, and heat mapping. Excuse me. So moving on to Um, when do you start tuning your databases? Well, you start immediately, and importantly, you have to do it continuously. Database tuning is not a one-time thing. I wish it were, but it's not. Database, the data in the database changes. The profiles change. Those histograms on your statistics, they change. Your indexes may become fragmented, which might not be a huge issue, but they may become less effective with the volumes of data. You may need to add some additional indexes or some filters, or maybe do some type of partitioning, which we usually don't have to get into. But the point is that if it's not performing one day, you work on it and it's tuned and it's performing the next day, that state of smooth running is not guaranteed to last 6 months, especially if you have high volumes of data. So yeah, there's no sense to lose customers or lose any respect or whatever you might have, clout over issues that are easily fixed. Again, if you can monitor them, if you have the information you need to diagnose a problem. Um, and proactive tuning is always best. That's the immediately part. If you think about it, the alternative to proactively tuning your database is quite literally waiting on someone else to say, "Hey, this is now unacceptable," and now you're not only do you have to kind of deal with that little bit of fallout, but you have to start trying to tune this thing under the heat of, hey, we're not working right now. What's going on? Why can't we get into stuff? And you're usually not going to come up with the best solutions in those situations. Lastly, and I've actually mentioned this 14 times, I think, but database tuning is continuous, but it's best left to a monitoring tool. Just because we say it's continuous does not mean that your job should become just watching the database all the time or writing scripts to pull the stuff out. Uh, Manually gathering that data is certainly a possibility, but it's typically woefully inefficient on your time. Uh, Back to the win, or staying on the win, not having a tool not having a tool to quickly find and fix problems causes lots of issues. You've got that increased time to resolve, to to actually come to results of your performance tuning. You're going to have your unhappy customers and employees, and what you mean by customers. We're not just talking about the people that come to you and purchase products from you, but your internal IT customers, the people that rely on you. Impact to business operations, and increased cloud and hosting cost. And but increased cloud hosting cost, license cost, those two are together. And there's actually a lot that goes into those that I don't think a lot of the higher level IT folks really think about, which is best summarized as folks often talk about SQL Server licenses being very expensive. Well, they're not inexpensive, but they're also not as expensive as you think. The whole perception that these licenses are extremely expensive are because when a database becomes slow, they will often throw resources at it. And those resources come at a cost. If you're adding CPUs, you're going to definitely be incurring costs with licenses. If you decide to add a second server because, hey, server A is now at high utilization and it's, you know, its memory is consumed, its CPU is at the top, and the disk are just thrashing all the time, and you add a second server. Well, I mean, now you've got licensing costs, and you've got a whole lot of new hardware costs and operational costs keeping it up and running. There's hardly ever any reason to continue to scale up and out unless we're talking very large scale and very high volume. So, what are tool? We're gonna talk about various tools, and one of the tools is ours. It expands that window into the database, and it gives you a comprehensive view of what's going on under the hood. Outside of just what's your CPU look like, how much memory you're using, and is your disk fast or slow right now. We really want to know a lot of what's going on. So we're going to allow you to look at hardware configuration, database configuration, and what's important about that is, from kind of that 10,000 foot view, you'd be able to see things like here are my 10 databases or my 1,000 databases, and here are the ones that are in full recovery model. Maybe here's the ones that are in simple recovery. Here are the ones that have things like auto close turned on or auto shrink, which are, scary and big no-nos in database land. Uh, so things like that really jump out at you with the hardware configuration. I mean, we actually had a customer just the other day installed and found out right off the jump, just from that high level view, that they literally had, I know it sounds crazy, a 500 gig log file that hadn't been backed up in a couple of years, and they just didn't know about it. But they got a whole lot of SSD space back. Uh, but it's also going to allow you to look at hardware changes over time, which might not seem significant, but when your performance suddenly decreases, it's very useful to be able to correlate that to uh, maybe processors being removed or memory being halved, which is super important in today's world with virtualization, VMware, Hyper-V, etc. Uh, because hardware can change. Also importantly, and super counterintuitive, is adding hardware can make your databases slower. Things like adding additional processors. Hey man, we're going to double the processors. We're going to go from 8 to 16 and everything's going to be great. We got twice the horsepower. But what you might actually have is twice the contention. Uh, you might have a lot more deadlocks. You could have plans that suddenly start to use, massively parallel plans that aren't as efficient because things like the max degree of parallelism hasn't been set right, or the cost for parallelism threshold hasn't been set. Things that you're going to need a tool to tell you, hey, things changed on this date, and maybe that's why the performance isn't what it used to be. Let you correlate that really, really quickly so you can get back to business. So, it's going to show you things like your index contention, which, basically is where we're having deadlocks because, we've got a lot of unused indexes. Allow you to view historically your execution plans and uh, things of that nature, like your storage performance and just a lot more than we'd be able to go into in probably this short time. So, the solution. We talked about the time to do your tuning is now and forever. So the phase one is to address your existing bottlenecks. Uh, Come in, find those low-hanging fruits, find the terabyte log files, get those things truncated, find the top 2 or 3 queries that are just, begging for an index or maybe slight changing criteria, and get those things out of the way so that we can start, add some oil to the system, get it actually moving smoothly. And then we move into the maintenance where we are basically just monitoring and maybe getting alert when things start to become a little bit out of phase so we can, again, proactively attack them and keep things running smoothly. Uh, our tool, the Vroom Performance Suite, we had a lot of design goals, and we're going to get into some what I think is fun stuff, looking at like a live system and how you might identify uh, poorly performing queries and how you can make some small optimizations. But I do want to point out some of the design goals. Basically, we have a couple of founders, myself included, who were uh, uh, we were in a very challenging situation with nearly 400 SQL servers that were all physical at the time, and we couldn't find a tool that would monitor them all. Uh, every time we would throw one tool at it, it would basically the UI would hang, or it wouldn't collect often enough because it's kind of going through them linearly. And just for one reason or another, every one of the tools was really cool, but they were all missing something that maybe the other one had. And we were trying to find a way to create an intersection of all those tools. And that's what we've done. We've created a tool that doesn't have a lot of impact, where we've created one that doesn't require you to add anything to your server. There's no software to install on a server to be monitored, though you can install it on the same server that you're using. There's no objects created in the database. There's no tables, no jobs, no traces, none of that stuff. And we also wanted just like almost forensic levels of detail. Uh, I mean, no one ever got into an issue where maybe something blew up, on your system, and they're trying to diagnose the problem. They've never said, "Man, I wish I didn't have this much data." As long as you have a way to parse it, everybody likes data when they're trying to solve a problem. So, yeah, high frequency of data and a lot of richness to the data. Okay, so we have kind of that single pane of glass. We're trying to get to the point where we have the ability to give you a tool where you don't really have to go anywhere else. You don't have to go to SQL Management Studio. You don't have to go to Windows Perfmon. You don't have to RDP into a box. Don't have to break open a Plan Explorer. Just we're continually adding more and more. But those are the goals. You don't have to leave. Uh, you can see what's on the screen. I don't want to go into any of the boring stuff about Active Directory integration and things like that, but uh, we monitor health, we monitor performance. We allow you to sort and group your servers into tags and also create lots of alerts. Some that are canned, a lot of canned alerts, and create additional alerts. And those alerts can be also set to tagged computers where, maybe these set of people know about storage problems and this other group knows about performance problems. And whenever you add another server, you tag it and it automatically inherits all of the same things. So we also, on this, the metrics can be trended at various levels of granularity from years down to the collection interval. Uh, we have a small built-in data warehouse as well, so we aggregate all the data. So when you look at something like the yearly performance of a query, if you're looking at 10 years worth of data, you're only looking at 10 rows. So you'll find that the performance of the monitoring doesn't degrade over time. We've actually got customers that have several hundred SQL servers, been running our tool for many years, and it's as responsive now as it was when we put it in. And we actually do a bit of consulting for them, so I'm usually on there tinkering, and it definitely is still snappy. Uh, so yeah, years worth of data is a really cool thing to have. A lot of people don't really think about, why do you need performance data for more than just, the last week or two, to kind of get some sort of a trend. Well, you have those companies that do some sort of year-end processing, and it's very useful to see if your year-end processing is getting slower, or if the things that you did to try to make it better throughout the year were actually effective. So yeah, a lot of history, a lot of data, and rich data. So yeah, we support SQL Server 2005 and above. Sorry guys, we discontinued SQL 2000. We started with it, but we started supporting it at one point, but yeah, it wasn't worth it. Uh, yeah. So yeah, database catalog, your database metrics. We can look at the files, the actual individual files, look at IOs on the files. We can look at that later if anyone's actually interested. Uh, do index suggestions and uh, basically notable queries where we just try to give you the queries that are going to be, you know, probably most interesting to you in a performance conscious environment. I'm actually going to check the meeting here, see if there's anything that's been coming in on the messages. So yeah, I only have one more of these slides of just kind of metrics dumps. But weight type performance, if you guys are familiar with some of the other tools out there, you'll know about weight types. These a lot of these tools are really heavy on weight types. It's basically, here's a SQL statement. It ran for 10 seconds. What took 10 seconds? Was it executing or was it waiting? Was it waiting on the network or a disk or a lock? What was it waiting on? And we do that as well. It's a really cool way to look at, it's a really cool approach to trying to squeeze a little bit more, air out of a SQL statement. So yeah, we look at all the weight types. You can ignore some of them if you want to. Technically, you can actually turn them off so you don't collect them. It's pretty nice. Uh, yeah, we monitor backups. We monitor performance counters, blockchains. Uh, uh, we also monitor deadlocks, which I don't know if I actually mentioned, but we got a pretty cool breakdown of deadlocks and kind of the circular reference to allow you to figure out what caused it and get to a resolution pretty quickly. Uh, on the Windows side, we also monitor the Windows server itself, which I think is something that's neglected a lot of the times. When we talk about monitoring the Windows server, people might think, well, what do you mean, like CPU usage? Well, yeah, but we do more than that too. So we actually monitor the network adapters. So we're going to look at your bytes in, bytes out, frames. We'll look at error packets, connectivity issues. We can let you know even when your machine's down. We can let you know that it's down, even if it doesn't have access to connectivity, which sounds a little odd, but we can. We monitor programs that are running on the server. So one scenario that I've dealt with a lot, and this is hotly debated, so I don't want to get in too much trouble throwing the opinions out there about antivirus. But people talk about antivirus on the server. Is it a good thing? Is it a bad thing? I mean, wouldn't you like to know how the antivirus is using the resources on your server? Well, with VPS, you can actually see throughout time how many cycles of CPU your antivirus has used, when it uses memory, how many handles it has open, how many threads it has. It's really nice to be able to say what happened on Thursday and go in and see that, as crazy as it sounds, it looks like somebody opened up, a 10 gigabyte text file in a server and just called SQL Server to flush all of its memory. While that's kind of an odd example, I've seen it before. Maybe it wasn't that big, but the tool actually showed that to you, and you can see what happened, when, why, and who did it. Uh, okay. Uh, Room for IIS. We also monitor IIS. So it's kind of basic monitoring. It's not our bread and butter, but we do monitor IIS for uptime. We monitor the application catalogs, app pools, and just some of the basic metrics. So you can actually use VPS as well to see if that fave icon is missing and you're getting 404s. And what makes Room different? The competition, the other folks that we've used in the past, I don't even like to think about them as competition. They're really just the gaps we are trying to fill. They use a lot of averages, and averages just aren't really what you need when you're trying to determine what's going on. You've got a SQL statement, it's run a billion times, and maybe one of them it took a day to run. That's bad, but on average, it's actually not going to look all that bad. Let's see if I have any chance. I'm just looking over the chat, guys. So, and Charlie, you were saying on the chat there that it really is so important to be able to see what else besides the DB is running, so and causing problems. Another example is someone leaving their browser open on the server, and that for some reason is taking resources. I'm glad you said that because uh, it's not necessarily Chrome's fault, but you'll see a lot of times that Chrome will sit there and chew a ton of resources just because it's sitting on some type of really fancy website with some HTML5 that's got some animations are going or whatever. And yeah, it's really nice to be able to correlate performance problems to things like that. Also, we've got, and of course, this is true as well for the server where ColdFusion or some other app servers running. And Charlie's saying he concurs that he's seen antivirus tools causing considerable negative impact, especially for disk I/O, especially if antivirus is running real-time scanning of all file writes, or worse, all file reads. And yeah, that's actually ours too. Even installing some tools can take a long time, just because like Windows Defender is literally scanning every single one of the files involved in the setup. So again, where you land on that side of the debate or not, having the information about any of those types of conflicts is it's indispensable. Once you have it, it's difficult to go without it. So also we've got powerful alerts. Alerting to me is it's super important. If you've got a tool that knows something that you don't and it doesn't tell you, it's not really doing you a lot of good. We talked about being proactive, but sometimes you need to know when something comes up. So the alerts are actually designed to be immediate. We've been in situations before where we've used some tools where a disk filled up, a customer complained that something didn't work. We engaged our IT folks to resolve it. They got it fixed. The disk is now, it's got some additional free space because they threw some more at it because it was a VM. And literally after everything's resolved, we get an email, an automated low disk alert, which, I mean, that's just not very useful. So the alerts are actually processed at the same time that the data is inserting into the Vroom VPS database. So if we know about it, you know about it. And yeah, we track the changes, the size of disk, memory, and all that stuff as well. And we've got here that it does not run on a production box, so we don't have any impact on production servers. But I do want to point out that it also runs very well, just all self-contained on a server with, your application, your database, and your performance monitoring tools. Uh, if there's the possibility to have, if you've got an environment where you've already got the footprint, it's cool to have your monitoring tools setting somewhere else. But when you don't, it's about as lightweight as you're going to get. All right, I've only got 3 slides here. So I'm just gonna glance over this pretty quickly. It's basically a case study that we did at company Old Castle Building Envelope, which gave us permission to use this data. Uh, they're they're a large company, quite a large company actually, and they basically had issues where they quite literally were having issues putting in orders with customers standing right there. These folks, they build the glass envelopes on skyscrapers. Uh, once I did work with these people, when I go to restaurants, if I go anywhere, I always look at the glass and see little Old Castle logos in the corner. Like they if it's glass, these people make it outside of Corning, but uh, they would have customers and contractors sitting there trying to work with them on designing building envelopes and couldn't actually complete the work because of database performance issues. It was awful. So they started looking for ways to resolve it. They brought in a couple of lightweight consultants, and they also had tried a couple of tools, and they already had one installed when we got there. And through some connections, we actually got in touch with them, and they agreed to give us a chance. Uh, we installed our tools and configured to monitor their SQL and their web servers. Again, these are separate servers, but we can monitor utilization of both at the same time and see how they correlate. And over a 10-day period, we collected performance data and statistics, and for benchmark purposes. And for 5 weeks, we were creating a weekly report containing specific recommendations that we gave to the folks to implement. And this was a fairly long engagement, but it was basically a database sitting behind an application that had been neglected to death. And um, when we talk about those top 10 queries, I mean, I think this thing had a top 1,500. It was out there. So basically, it was every single week we would go and we would find those top, two, three, four, five, however large they were, and break them down, and then come up with recommendations. Whether those recommendations were, changing sprocs or adding indexes, for removing indexes, things like that. There were a lot of things, a lot of specifics that went into it, but at the end of the day, when we were done, they had a 60% decrease in their CPU utilization, which was evident in the tooling. 92% decrease in the logical reads, which is very large. Uh, they had a nearly 90% decrease in their deadlocks, which actually was their largest problem. I mean, they deadlocked constantly, and we worked with their folks on their help desk to come up with the number. Uh, Again, I hate really specific percentages, but it's the one they gave us. It was a 73% reduction in their help desk support requests. I mean, they actually had relief from their help desk folks. Just tuning a database, people are now getting some additional rest. It's the coolest thing. Uh, so yeah, is that it? Yeah, I think that's actually it for my slide deck, uh, whatever you want to call it. So I actually wanted to give a very uh, a quick demo. Unless people want to go in further, I'll spend the time with you. But yeah. So we've got the chat. Does anybody have any questions at all before we kind of dig in? So Brett says it seems like this is a SQL Server specific. It is. It is SQL Server specific, but we also support Azure, and we're looking at Postgres, MySQL, and Oracle. We basically just had to kind of pick a path and be as good at the one thing as we could be at first until we start to add additional components. And it just made sense given the history and where we came from to start with Microsoft SQL Server, Microsoft Windows, IIS, and and also Hyper-V, which we've already extended to the VMware vSphere. But yeah, definitely Microsoft stack with plans for short-term plans for Linux as well. Okay, so again, feel free to drop any more questions if they come up. I'm just going to drop on into a demo. Again, look, I've got a demo that takes forever, and I'm not going to go through it. It touches just about everything, and we go into a bunch of specifics. I just want to show the tool, let you see that there really is a tool behind that PowerPoint presentation, and just kind of let you see some of the data that we're talking about. So when we first open up EPS, we'd be looking at something like this. It's basically a quasi heat map that's going to show you health status. Health status is completely driven by alerts, and we can go into alerts if anyone wants to look at any specifics or have any requests for alerts. But basically, if you have an alert that says, "Let us know when CPU is over this or over that," uh, if that alert is triggered and it's of a warning or it has a severity, anything from informational, warning, critical, those are going to drive the states of the servers, and they're going to drive also the server explorer over on the side, showing you kind of how the health is performing. But just pick on one, this test 2016 box. So we could see that we've got a database pending recovery, and we can go straight to the database and see that, oh yeah, there it is. There's one that's pending recovery that for some reason didn't come back up after a reboot. Of course, that's an email you would have got. At the end of the day, you would also get a digest email with kind of a summary of alerts, uh, or both. You can do both. Um, so yeah, that's kind of basically what you'd be looking at when you first open up VPS. But what I like to do is typically look at my performance snapshot. Performance snapshot is just going to be that kind of data warehousey look of the database we were talking about before, of your server rather, where we've aggregated everything and allow you to kind of dig into it and look what it looks like over time. So we see here that we're looking at a week. We can bump it out to 2 weeks, and I do have to apologize for the recent activity that picked up last night. We actually moved from a virtual environment back to I'm sorry, a hosted environment back to a physical environment for our demo stack, so that we could do some work with VMware. But nonetheless, we've had a lot of activity over the last 24 hours. That'll make the next demos kind of maybe cooler. But from here we can see the number of executions per day from 6.5 up to today, and those are broken down. The colors are by database, so we've got a word list, and we've got the MSDB, we've got this Network DLS com, and down the bottom AdventureWorks, good old AdventureWorks. So we can basically see from a high level which databases it is that is executing the most queries. We can also see the duration. So top-notch ERP most definitely has the longest running queries by far, clearly. But again, I mean, it's clear. We can see where the high duration is. If you've got consistently high duration, you might see the things flat, but maybe they're really high. But when there's an anomaly, it sticks out like a sore thumb. Uh, the important thing is when we look at a database query duration like this, we can actually double click on those and we can drill in and we can see the duration. So, here we can see that we've had 471 executions of this query. Doesn't look all that bad, but it's taken a lot of time. It has an average duration of 44 seconds, almost 45 seconds, and a good deal of wait time. We can drill into the individual 471 executions, and from here we can see where they ran from, who ran them. We can see the wait time. We can click on the wait time. This only had one wait type. It was async network I/O. So we can see how long it took. We can see a description of the wait type itself, whether it was waiting on disk or whatever. And we can also drill and look at the plan. We're going to look at a better plan. I actually took some notes on some plans that have some meat behind them and multiple statements. So I'll move away from that for the time being. So yeah, that's the performance snapshot. So yeah, got some duration sticking out like a sore thumb, and we can also see the logical reads. Who's doing the most logical reads? Who's doing the most physical? Who's writing the most? And who is chewing up my CPU? So we got this simul support reports, which is using most of our CPU time. Just like the duration, we can drill into this and we can see the individual queries behind any one of these bars, search them, sort them, filter them, and drill all the way down to the individual executions and see who, when, where, why they ran and its plan and any suggestions. So this is your retroactive view. This is basically I just want to see. It's not necessarily retroactive because it includes today's date as well, but it's for looking into the past. Kind of seeing how things overall are, how they're kind of measuring up to past activity. We also have current activity. So current activity is just like the one you were looking at a second ago, except for it's not aggregated. This is data which is being pulled off of whichever server you currently have focused, where you can see what's going on right now. Um, these are all expandable just like they were on the other screen, but more importantly, there's data behind these. So when we look at things like the database CPU, I mean, we've got a dynamic list here of which database is consuming the most CPU time, and in this case, it's MasterDB. But wanted to look at things like the request per second. Well, we'll look at the weights first. So your weights, you see a sync network IO and CX packets. There's a couple of CX packet weights in there, but for the most part, it's a sync network IO. Uh, as new weight types are encountered, they'll be dynamically added down here at the bottom. But this is another place where you can see some really clear sore thumb issues. If you have blocking, you'd come in and you'd basically see, a 45-degree angle where you've got this thing that's been blocking for a really long time, and it's just the wait time for that particular lock type is just adding up. Also, blocks will be showing right above it. On the request per second, we've got requests, compilations, recompilations. So we see that we've got a lot of requests coming in. Less of them are being compiled. That's a good thing. And we've got recompilations. Basically, we're not recompiling a lot of statements. So we were marrying up to our execution plans pretty well. So Charlie asked, speaking of showing what's happening now, are you able to show what queries are running now, sortable by duration, not just the wait time, and showing the SQL? I'm glad you asked because yes. So these are drillable. So if we drill into the requests, we would see the SQL statements that are running. What you're seeing here is again, it's a real-time view. It's a snapshot that's pulled fairly quickly, which is configurable. And you can see it was just updated. It's I guess every 5 seconds or so. Yeah. And from here you can search and sort. So we see that we've got duration. We can sort that by duration. You don't have any with a duration right now because none of them are actually running right now. These are just connections that are made, and these are their latest SQL statements. But if we sit here for a couple of seconds, we'll see them come in with durations. There we go. There's one with the duration. And we can click on the enquid to see the query itself, or we can click on the SQL text to see the actual SQL text that came over. Um, what's really important about this is that even when you do have a real-time view without any context doesn't do you a lot of good. An example I like to give is you've got a SQL statement that runs every day for 10 hours. You've definitely got a problem if you've got a SQL statement that runs every day for 10 hours. But if everyone's happy and everything's running pretty smoothly, and then one day someone tells you, hey, this thing's so slow I can't use it, you would come into something like this and you would see, oh man, there's a query here. It's running for 10 hours. But without the context of, hey, that's always does that, you might lose focus or go down kind of the rabbit hole and start chasing this 10-hour long query. Even though it's certainly a bad actor and you need to get back to it, maybe jot it down and we'll tackle it after we get done with this firestorm that is everyone saying the server's slow. Without the context to see that that statement always does that, it could be a distraction from the problem that you're having right here and now. So when we see things like we have this duration, we can double click on this and we can drill into the actual query itself. And though we saw that it was running for, 42 seconds, we see that it usually runs for 45, 46 seconds. So that's actually pretty normal for that statement. Does it need to be tuned? Yes. But if we're currently having a uh, abnormal time with our performance, that's not a problem. And again, we can continue to drill from here as well. Okay. So Charlie says a great point about having the additional context of whether a given slow statement would be always slow, and to perhaps accept it for it is what it is. Yeah, so we also have the ability to ignore SQL statements as well if you just really do not want them bothering you anymore. We'll get into some of that. Yeah, we can do that. I'll leave it for another demo. But you also see here we have this notable query ID 418, which is what we call them, and it's called prod delete. Sounds bad, but if you look at it, it's a SQL statement deletes from production, and we've aliased it. So we can right click on these NQIDs as we call them, notable query IDs, and we can alias them. And then wherever you look for them, whether it's searching for them in our notable query search, which I'm going to look at next, or the real time, wherever you see these things, they're going to have the same alias. So you can track them over time. Also, the notable queries. Uh, we have a proprietary query hashing solution. So some of you may have heard of the logic hash that SQL Server gives, where it basically comes up with a number, a hash that says these two statements are alike even when they're slightly different, or maybe they're only different by some constants like numbers. You've got a query, select from employee where name equals John, and one where name equals Mary. Their statements are the same. They just have two different hard-coded constants. Uh, so the query hash is useful for that, but it's actually not that reliable. It changes. Uh, and also it changes from version of SQL Server, from service pack to service pack. And sometimes it's just different regardless of service pack edition and SQL statement. So we came up with our own so that we can monitor and correlate the same SQL statement across instances, across databases, and across time. The hash doesn't change. So if we call this thing prod delete and we see this query again, regardless of the join order, regardless of the parameters, regardless of white spaces and comments, it's going to be notable query ID 418. So if you make changes, we can, tell that the query is getting better or worse. Uh, Also, if you guys have used SQL Management Studio before, you've probably played with the filters, and you might know how kind of aggravating it is to try to set up filters only to have it refresh while you're in the middle of it. So I just wanted to make it clear that you can actually add filters and you can drag and drop and sort and group and all that from here without worrying about the refresh messing up your 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 the process of adding those filters. Okay, so moving on from the activity monitor, I'm going to look at the alerts. I said I was going to look at the notable queries, but I did just want to touch on the alerts really quickly. So this is a list of the canned alerts that come with VPS. Uh, they're quite simple. If you look at the critical CPU alarm, this is CPU greater than 95%. We can double click on them and we can see that basically we poll, and whenever we see the CPU has been above this threshold of 95% more than 5 times in a row, we send an email. We send one email, only one. We'll not send you a bunch of emails. We'll only send you another email if this condition clears and then reoccurs. So yeah, a lot of canned alerts, and there's a lot of categories. So basically, we've got computer metrics, computer performance. Uh, you know, pick one. We'll look at something like just the computer performance. Once we pick computer performance, we can set up some of our high level things about the alert, give it a name, and then we can add conditions. You'll see that all the conditions actually have a little bit of help associated with each one of them, so you can tell what it is that you're actually working with. And again, once you set up these alerts and set their conditions, they're real time. Uh, send them email, SMS, and even very soon make phone calls with automated voice. Okay. So on to what I was going to show, which was the notable queries. This is a place where I spend a lot of time. I'm one of those guys that you run into two types of people: the folks that like the charts and the people that like the tabular data. I'm one of the tabular people. So on notable queries, this is where we can come and we can just do some searching. So just hit the go button, and these are the queries that VPS has determined are notable over the last day here in the filter. Uh, so from here, you can search for queries, you can sort them, you can basically try to find your top queries from here. You look at the duration, see what comes to the top. There's our highest duration. Its average is 45 seconds. It's been executed 35 times. Uh, we can do things like if we just wanted to look at ones that have select in the text, we can look for selects. Maybe ones that also only have order in their text. So this is another thing that I find is missing from some of the other tools is just the ability to search by text. Your query's out to the side, but we can also click on it and bring it up. uh, so yeah, I'll go and clear out the search, and we'll sort by the missing indexes. So we've got one here on the top with two missing indexes. We can change the time frame and maybe pull in more, but you can see in one place we've got the same table, two different index suggestions that have been pulled from plans. Uh, and we can kind of see the two variations. Actually, they're both for the same query, and the smaller one actually looks like it's got a little better impact. So yeah, there's your index. We also have a index search where you can just search for indexes, just the same way that we're looking at the SQL statements. But given the fact that we're about 8 minutes, 7 minutes short of a top of our hour, I'm going to avoid digging into that unless someone wants to. Uh, at 372, yeah, 372. So we've got this query 372. I'm gonna look at the 52 executions, and just looking at this one really quick, I see that we've got plan cost of 5.38. I'll click on the plan cost. Okay, actually, pretty sure I had a better one to show you, but now I'll just go ahead and drill in and look at the subtree anyway. So yeah, this is one of the cases where we had a plan with an index suggestion. We can see the index suggestion on the plan as well. You can right click on these and look at all the properties, same as you'd have in SSMS, and also export the plans if you wanted to use them in an external tool. Let me see. Look at the last thing I wanted to show you on this screen is just the weight types. So I actually had a particular one I wanted to look at, which was notable ID 41, which I noted earlier today. So I'm gonna look at these 5 executions, and I believe that this thing was a little bit earlier than that. I just back it up a little bit. 618, 925. I believe that's the one. Oh yeah, this one actually is a pretty cool plan too. I was going to look at the weight types, but you see here, this is create sales aggregations from production. It's a stored proc, but it's got a bunch of individual statements. And what VPS has done is broken down each one of the statements in the sproc and shown each one of their individual subtree costs and plans. So we can drill into those. But yeah, I'm here to look at the wait time. So the wait time on this one, yeah, it's nothing major on this one. But you can see that of the 14 and a half seconds that this statement waited, about 14 and a half of it was CX packets, some parallelism waits, and 58 milliseconds of page IO latch. So yeah, this thing's not necessarily IO bound, it's a little more CPU bound in a sense. So again, top of the hour. I could go on all day, but I know you guys aren't gonna let me do that. So does anyone have anything they'd like to ask or like me to look at?
I'll tell you what, while we await Joy, who's typing there, let me go ahead and switch to the overview and evaluation. So as people maybe need to go at the top of the hour, you can start filling out these evaluations. But now you'll be able to see Troy's or anybody else's comment in the middle. And then if you need to switch back to show something, just let me know and I'll switch back. So you see that, Josh?
Yeah, yeah. So when it comes to Century One, actually we kind of mm, Century One was one of the tools that I was using in the past. My biggest concern with Century One was really the scalability, which I understand may not be applicable to a lot of people, but uh, Century One was literally the reason that we started because we were having issues with the volume of servers and the amount of data that we needed. It's actually the one that I mentioned in my examples of you know the screens being kind of frozen and it kind of taking a long time to load things. The other thing is that Sentry One, formerly SQL Sentry, it's kind of event based. You know, you'll see that a lot of it is about events and when they happen and kind of showing them on sort of a Gantt chart. And it's also a tool for designed and targeted for database administrators. And we try to venture outside of just database administrators and try to cover the whole swath of the QA folks, the database developers, excuse me, and also the database administrators to give you those things that we talked about, you know, the weight types and the high level stuff and the drill throughs. And if you look at some of the stuff that we definitely could not get into today, the drills into the individual files, the drills into the indexes, so we can look at index usage over time and see, you know, what indexes have been used, how they've been used. Uh, uh, I think you'd see a lot of advantages to the some of the heavier stuff that you could just kind of shave off of a SQL server over just a couple of days using tools like ours. Um, so yeah, I hope I answered that with the Century one.
Hey
So when
Troy,
we
this
roll
is
out support for
Mark.
other DBs, yeah,
Hey Troy, this is
yeah, go
Mark
ahead, Mark.
too. I just wanted to. I work with Josh. Yeah, as far as Century One too, if you want to contact the Sapper, we would love to give you a demo. And if you use a Century One, we got a great deal you can't pass up anyway to switch, and we'll give you a whole lot better tool.
Brett, you were asking about the support for other DBs and non-Microsoft servers. So yes, Linux is. We actually have to support MySQL. It's just asked so frequently. So we're going with MySQL, and you know if you're running into MySQL, they're probably running it on Linux. So Linux and MySQL are top of the list, and we are also working on SQL Server on Linux. So yes, Linux is on the short-term roadmap.
Do you see Troy's questions regarding recommendations?
Oh no, I actually missed that. Where are we at? Oh, does the tool give recommendations? So yes, the tool does give recommendations. We give them basically in two ways. One is from the data that we scrape. So we're looking at statistics and indexes and recommendations around those, which the indexes are pulled from the plans. The statistics are something that we do, and also the another type of scraping we do on indexes as well. So there's some recommendations around those. So those are the types of things we pull, and the other ones are the ones that we actually process in the data through the alerts. So we've actually got a bunch of informational alerts that are basically canned recommendations that are saying when this condition occurs, you need to do this. So they show up on your dashboard, and I mean those are things like if VPS notices that you're running a SQL server with a database on a disk that's not formatted with the proper allocation granularity, it will let you know that you need to reformat the partition for optimum performance. So there's a host of things like that that VPS is going to point out and say, these are things you need to do to optimize. As far as the
Hey,
time
Brett.
frame is concerned, that's up from Mark. I'm not familiar with the time frame.
Yeah, Brett, I was going to answer that. I was going to say we're looking at trying to roll that out in the next 3 months.
It's actually really nice to have some folks engaged as well. Yeah, thank you everybody for actually chiming in. I appreciate it. How long is the demo
Hey,
period? If you're talking about the trial, it's 30 days, and the license for that is just it's automated in the setup.
Okay, well, that seems to be the last of the comments and questions. And who knows, maybe somebody might be waiting to ask one off the recording. So let's go ahead and stop the recording. Yep, I'm glad you shared that link. There you go. Perfect. And is there anything else you might want to get in before I stop the recording? Anything either as a link or to say? Either of you guys? And I'll say thank
I
you
would just
for.
say thank you everybody for coming. And again, he shared the website. And also, if you want to email us at info@vroomperformance.com or give us a call, we'll be glad to help you out. And even if you just got questions about databases, we help people all the time. So give us a call.
That's awesome, dear. I'll wait and see what Brett's typing there. Wondered if I might have picked up on that.
Yes, North Carolina.
Oh yeah, we're in Charlotte. Yep.
Yeah, we're in Salisbury, so just north of Charlotte. Yeah.
Oh, I'm actually in South Carolina,
But
so we
if
can triangulate.
you got time, we'll come sit down with you. If you got time, we'd be glad to come show it to you. Or if you want to install it and help you get it rolling, we'd be glad to do that.
Very cool.
That's awesome. Like, what are the odds?
Right. All right, so with that, I'll go ahead and stop the recording. Thanks again, guys, for coming on, and everybody check it out, and we'll look forward to announcing soon the upcoming next meetings. Thanks, everybody, for coming. Till the next time.
Thank you, John.
Thank everybody.